In Fancade version 1.4, we've got 9 new script blocks. So in this video, I'm going to show you what these new script blocks do and how to use them. The first block is the frame counter. You can find this frame counter in the game folder in the inventory. And this block is pretty simple. It outputs the current frame number, starting from 0. So on the first frame, which is, well, actually the 0th frame, it's going to output 0, and then the next frame it outputs 1, and then 2, and 3, and 4, and so on. So it increases by 1 every frame. Previously, you had to define a variable for yourself, and then increase it by 1 every frame using a script like this. But now it comes as a built-in script block, which is really handy. All right, so the next two blocks are the increase and decrease number blocks. And both of these blocks can be found in the variables section or folder on the very bottom. And these two blocks simply add 1 and subtract 1 to a variable respectively. And this is just a shorthand way of doing this. However, it takes up a lot less space. Inside the control folder, there is a new block called the loop block, and it looks like this. The loop block is used to run the same script several times. It has two inputs, start and stop, and so the loop block will start looping from the start value, and then it will stop once it reaches the stop value. And while it's looping, it's going to execute this do wire here every loop. The counter output outputs the current loop number or iteration. So in this example that I have right here, I have a loop that goes from 1 to 10. It's important to note that the start value is inclusive, but the stop value is exclusive, which means it's going to stop looping as soon as it gets to the stop value. And so for this reason, you put 11 instead of 10 as the stop input. You can see if I change the stop value to 10 instead, it's actually going to loop, well, still 10 times from 0 up to 9, and then it's going to stop at 10. If the start value is larger than the stop value, then the loop block is going to count down instead of up. Previously, to create loops, you would need a setup similar to this, but now all of this has been packed into a one single built-in script block that takes up very little space. You can still make traditional loops like this, though, if you ever wanted to. The next block we're going to look at is the late update block, which can also be found in the control folder, same folder as the loop block. This is probably the most powerful script to be added of them all. The late update block will execute scripts after physics have done calculating each frame. So to understand what that means and why it's useful, we need to understand the order of steps that are taken in each frame during play. The first step is to run all scripts in the game. Next, the physics are calculated and updated. And for the last step, the frame is drawn to the screen. Now, of course, this is a major oversimplification, but that is the gist of it. What the late update block allows us to do is to execute scripts after the physics step, and this is incredibly useful. It has so many uses that we haven't even discovered all of them yet. But here are a couple of examples. You can create invisible physics objects. Previously, you weren't able to do this at all because disabling the visibility of an object would disable the physics entirely for that object. But the late update block gives us a nice workaround. We can set the object to be visible before the physics run, and then we can disable the visibility for the object again after the physics have done updating. You can also turn collision on and off during play. This is also something you weren't able to do previously. You can also offset objects from their physics colliders. So the way this works is before the physics update, we set the position of the object to its collider's position, then we let the physics run, and then we update the collider's position, and then we just set the position of the object to some offset. And this gives us this cool effect where the object appears to be displaced from where its actual physical collider is, which is really, really useful. Okay, I don't actually know if it's going to be useful, but it's cool nonetheless. The possibilities of the late update block seem endless. These are just the first couple of use cases that came to my mind, but there are undoubtedly many more tricks just waiting to be discovered. The last couple of script blocks that I'm going to show you can all be found in the math folder. The first one is the logarithm block. Let's look at this one. So, as the name suggests, this block calculates the logarithm of any number by a given base. Another cool feature of this block is that it has its own built-in pun as an icon. That's right, the icon is a literal wooden log. Get it? Log? Logarithm? Anyway, next block is normalize. This block takes an input vector and shortens it to a length of 1. It'll have the same direction as the input vector, just scaled to a length of 1 unit. This is also known as a unit vector. This can be useful in many cases. For example, you can take a vector, then normalize it, and then you can scale that by any number to get a vector of any specific length. The next block on our list is the dot product. The dot product is a way of multiplying two vectors together. Now it's important to note that the dot product outputs a scalar, which is just confusing mathematical terminology for a number. It outputs a number, that's all you need to know. So what is the dot product? So the dot product is defined as the length of the first vector multiplied by the length of the second vector multiplied by the cosine of the angle between them. Okay, so why cosine? Well, it makes sense that we would multiply the lengths of the vectors together, but this only really makes sense if they are pointing in the same direction. That's why we multiply by the cosine of the angle. If we draw a triangle like this, the cosine will be equal to this length here. So we basically make them point in the same direction, and then we multiply the lengths. It works the same as if we did it for the other vector instead, because it doesn't matter what order we multiply in. The cosine of the angle between the vectors gives the dot product a unique property. We can, for instance, measure the angle between two vectors, which means we can check if two vectors point in the same general direction. Here's an example script that checks if two vectors, A and B, are less than 45 degrees apart. As you can see, we start by normalizing both vectors, then we take the dot product and check if it's greater than the cosine of 45 degrees. Here are some more properties of the dot product. If the vectors are perpendicular to each other, meaning the angle between them is exactly 90 degrees, the dot product is always going to be 0 because the cosine of 90 degrees is 0. So if we multiply the factors together, we get, well, 0. If the angle is less than 90 degrees, the dot product will always be a positive number. And if the angle is greater than 90 degrees, it's always going to be negative. With the dot product, you can check for any of these conditions. The last block is the cross product. Similar to the dot product, it is also a way of multiplying vectors together. This time, however, the cross product outputs a vector. The cross product is defined as the vector that is perpendicular to both vectors. the length of this new vector will be equal to the area of the parallelogram formed by the two input vectors. One unique property of the cross product is that if you take the cross product of two vectors that point in the same direction, or opposite directions, the cross product will result in a zero-length vector. The reason this works is because when the two vectors are parallel, the parallelogram formed by the two vectors will be infinitely small because it's been squashed into a line, which gives it an area of 0. This can be used as a quick way to check if two vectors are parallel. And those were the 9 new script blocks. Many of these new script blocks are mainly for convenience, as it has already been possible to make these as custom script blocks and has already been done before. The big exception to this is, of course, the late update block, for which I can't wait to see all the cool things that creators are going to do with it. If you have any questions about these new script blocks, feel free to leave a comment. I read all the comments I get, and I'll try to respond to questions if you have any. Thank you for watching, and I hope you learned something.